So some general points to be aware of with respect to calculating flux is that it's still a lot of steps. It's still calculating a parameterization, still calculating a bunch of things. And because of that, it's still very handy to have special cases where we have short methods for calculating this normal vector because it'll cut like 3 steps out of the work for us rather than having to calculate a couple of partial derivatives and then their cross product. But the direction of flux can be a little bit tricky as well, and that's something that we need to be very careful about. So here's a complete list of the steps that we need to do in general. It's fun. So the first is that we've always got to start with parameterizing our surface. Then we still have to calculate these tangent vectors by taking the derivatives with respect to u and v. We have to calculate their cross product to find our normal vector. Then we've got to calculate what's our vector field doing at this particular point. We take the dot product of that with our normal, and then we integrate. And then the final step is that we have to check direction. We have to make sure we understand what direction this is flowing through the surface. So, for example, this first case of parameterization, where we parameterize a flat shape like a triangle or a parallelogram, is nice because the normal is just the product of the cross product of the two direction vectors, and the direction is given by the right-hand rule. In the case of the graph of a function, if we can solve for z in terms of x and y, then here's a parameterization. Phi of uv is equal to u comma v comma g of uv. In this case, the normal, the cross product of these, is given by this formula, which we worked out when we were calculating surface areas of graphs. It's minus del g del u minus del g del v comma 1. And the normal always points up. The negative signs out in front get people confused a little bit. The reason those are there is that, when our function is increasing, when we're going in the u direction or in the x direction, the normal vector kind of rocks backwards a little bit. So this is a very handy formula to remember. It's extremely useful for calculating flux integrals over graphs. And so I would recommend you keep this one in your pocket whenever possible so that you don't have to do the calculation at length.